Problems involving sequences. So let us start with the steps in solving a math problem. So here for our first step, we must read and understand the problem. Sometimes we have to read the problem a couple of times in order for us to fully understand what the problem is all about. There are also situations that we must apply some reading techniques like looking for keywords or highlighting such keywords, and we also have to paraphrase the problem in order for us to fully understand the problem. And for number two, we have to make a plan for the solution. Here, in this particular step, we have to look for correct mathematical concepts or operations that might help us solving the problem. So in this step, sometimes we also have to make or construct our own explicit equation that solves the problem. But there are also cases that there would be formulas that we might be using to solve the problem. And for the third one, we have to work on the solution. And here in this step, it is actually the evaluation process or the solving process of the problem. And for number four, we have to check the answer. So here it requires to substitute the calculated value in the equation, and if the value gives us a correct equation, then there's a possibility that the answer is correct, especially when all the mathematical concepts or operations or even the equations used are also correct. And now let us proceed with the problems involving sequences. And for our first problem, Rhea was encouraged by her parents to save money. Her parents gave her a piggy bank as a gift with an initial amount of 1,500 pesos. She plans to deposit her money on a weekly basis for a period of 140 days, given the pattern of 5 pesos for the first week, 10 pesos for the second week, 15 pesos for the third week, and so on. How much will be the total amount of money she has after such period? So here you will notice that I have highlighted some of the keywords in the problem in order for me to easily look at the information once I reread the problem. And now let us write all the important information in the problem, such as the known quantities. So here we have an initial amount of 1,500. So let us simply call this to be the initial money. And here you would also notice that Freya plans to deposit her money on a weekly basis. So let us write such information here. So there will be such amount of deposited money on a weekly basis here. And it was stated in the problem that it goes with a pattern such as 5 pesos for the first week, 10 pesos for the second week, 15 pesos for the third week, and such pattern continues. And let us try to write such information here. So 5 for the first week, 10 for the second, and 15 for the third. And here you will notice that it actually comes with a pattern such as adding a 5 from the previous number so that we get the next number 10. And if we do the same here, adding 5 would give us 15. So this pattern continues until the last week. And obviously, in order for us to come up with the total amount of the deposited money on the weekly basis, we must add all those values as well. And since we do not know exactly yet what will be the last week for which she has to deposit a certain amount of money, then Let us try to look at this information. It was stated that the deposit will happen for a total period of 140 days on a weekly basis. And if we try to calculate how many weeks are there in 140 days, then we must easily have such by dividing 140 by 7. And it actually gives us 20 weeks. So that means that there would be 20 numbers here, and this actually shows an arithmetic series because the numbers actually form an arithmetic sequence by which we need to come up with the sum of all those numbers. Then it becomes an arithmetic series, and the last term would be the 20th term. And now we can actually solve the problem by having this particular concept of having the sum of the initial money that she has, which is 1,500, with the total amount of deposited money that comes with an arithmetic series. And looking at the information that we can have with this illustration, then our a sub 1 would be 5, while the common difference can easily be determined by having the second term minus the first term, which has a value of 5. And the formula for the arithmetic series that we would be using here, obviously, is the formula that only requires us such quantities of a sub 1 and the common difference. And here is our formula. And now let us substitute all the known quantities here for the a sub 1 and the common difference in our formula. And since we would like to have the total amount of money that she has for a period of 20 weeks, then the S sub n becomes S sub 20. And since the n changes to 20, this also changes as well to 20. And now for the value of a sub 1, we have a 5. And the n again changes to 20. And for our common difference, we have a calculated value of 5. And now let us simplify this resulting equation. So 20 divided by 2 is 10, while 2 times 5 is 10, while this gives us a 19. And now let us have the 19 be multiplied with the 5, and that gives us 95. And now here we have a 10 times 105, which actually gives us 1,050. So remember that this is only the total amount of the deposited money. So let us try to have it here. So the total amount of deposited money is 1,050. And now for us to have the total amount of money Freya has after such period of 140 days or 20 weeks, then it would simply be the initial amount of 1,500 plus 1,050, and there is a total of 2,550. And now let us proceed with the next problem. And it states that a film showing event organizer has estimated that a total of 162 chairs would be enough to fill the room if there would be 10 chairs in the front row, 12 chairs on the second row, 14 chairs on the third row, and so on. The question is, how many rows does the room has for the event? So let us try to illustrate the problem first. So let us assume that this is the first row and there would be 10 chairs on the first row. And based on the problem, the second row contains a total of 12 chairs. while on the third row, it has 14 chairs. And going back with the problem, we have a total of 162 chairs. And it was also stated that it would be enough to fill the room given such pattern. So that means if we continue with our illustration, the fourth row contains a total of 16 chairs, be followed by the fifth row having 18 chairs, the sixth row having 20 chairs. And here in the problem, we are being asked of how many rows would there be if we have placed all the 162 chairs given such pattern here. So that means there would be a total of 162 chairs. And if we look at the numbers here, it actually shows an arithmetic sequence. And since that we would like to have this be added in order for us to come up with a total of 162 chairs, then the concept that we will be using for this problem is the arithmetic series. And the known quantities that we can use for this are those a sub 1 as well as the common difference. And for our a sub 1, we have a 10. And for the common difference, we can easily have this to be 12, which is the second term, and 10 being our first term. So 12 minus 10 gives us a 2. And now, since we know that the total has 162 chairs, then we may have such quantity pertaining to the sum of these numbers be equal to 162 since we do not know yet what will be the total number of rows do we have after filling the room with such chairs in this pattern, then the n will be our question. And now for our formula. So knowing that we have the values for a sub 1 and d, the formula that we will be using is this. So remember that we have two formulas, but if we only knew the value for the a sub 1 and the common difference, this would be the correct formula. Okay, now let us substitute all the known quantities in the problem in our formula. So here we have the s sub n be equal to 162. And for our n, since we do not know the value of n yet, so it remains what it is. And for our a sub 1, we have a value of 10. And again, your n remains unknown, while for the value of d, we have a 2. And now let us simplify this resulting equation. So we have our 162 here. So this will still be n over 2. While 2 times 10 gives us 20, but the quantity of n minus 1 times 2 will give us n times 2, which happens to be 2n, and negative 1 times 2 gives us a negative 2. So we can combine these similar terms here, like 20 minus 2, which gives us 18. And the expression now would be 18 plus 2n. So let us simply write all the remaining quantities here. And now solving for the value of n. So we have this, so we may apply the multiplication property of equality so that we can eliminate such denominator here. So doing so, we have to multiply this side of the equation with 2, as well as the other side here with 2, so giving us 324, and this would give us, so we can apply cancellation method for this, and that gives us 1. And we are only left with n times the quantity of 18 plus 2n, which will then gives us n times 18, which is 18n, while this one gives us 2n squared. So here you will notice that there is a common factor for all of these terms, so we can actually have such common factor be extracted for each term, which is actually A2. Okay, so this will be the common factor. So let us divide 324 by 2, and that gives us 162. And dividing 18 by 2, it gives us 9. And we simply have to copy the n. While dividing 2n squared by 2, it gives us only the n squared. Now let us write a quadratic equation in this format. Having this 162 be transferred on the other side, applying APE, we must add the opposite of 162, which is negative 162 to both sides of the equal sign. So let me have it here. So this gives us a 0, while if we would like to write the resulting quadratic equation in the correct order, then we have to start with the quadratic term, which is the n squared. So since we cannot combine any similar terms here, then we simply have to write the n squared, followed by the 9n, and lastly the constant term of this quadratic equation. Since that you have already learned in the grade 9 how to solve for the quadratic equations like this, then now let us solve such quadratic equation. We can easily have this be solved using factoring. So here, so let us start with prime factorization of 162, just to start with the computation process. So here we can have this be divided by 2, and this gives us 81. And 81 actually is 3 raised to 4. So our goal is to have a pair of factors of negative 162 that gives us a sum of positive 9. And I guess we can simply have this be 3 squared is 9, having another 3 squared, which also be 9, and now multiplying the 2 with the 9 gives us 18, while this is 9. Okay, so 18 times 9 gives us 162. Since this is a negative 162, then one of these two factors should have a negative sign. And obviously, the higher absolute value should take a positive sign in order for us to come up with a positive 9. Doing so, we have the factors of n squared be n and another n, having the positive number here and the negative number here. Since 18 is higher than 9, therefore, it should take the positive number here, while 9 is negative. So to check whether these factors are correct, then we may simply have the positive 18 be multiplied with the negative 9 and check whether this gives us a product of negative 162. And next is to add the 18 with the negative 9 and check whether it actually gives us a positive 9. So 18 times negative 9 is negative 162, while 18 plus negative 9 gives us positive 9. So these factors are correct. And now let us apply the zero product property. Doing so, we have these factors of n plus 18 be equated to 0. This same with n minus 9. We have to equate this with 0. And for n plus 18 equals 0, we may apply the addition property of equality here by adding the opposite of the 18, which is negative 18, to both sides of the equal sign. Doing so, we have this n be equal to negative 18. While on the other equation, we have n minus 9 be equal to 0. Applying the APE, by adding a positive 9 to both sides of the equal sign, then we have this n be equal to positive 9. So these are the two possible values for the n. But notice that your n actually is relative to the position of the term in the sequence. And since there is no such thing as negative position, then this value of n, which happens to be negative 18, is what we call an extraneous root, because there's no such case of negative position here. So we only have positive 9 as our answer here. So that means that there would be a total of 9 rows.